video is not on the Mets, but
2.
on scatter
And
plots.
trend lines, which are also called lines of best fit, which we talked about briefly in the other video. So let's look at something. Okay, so here we have 2 scatter plots. This one right here, this has no correlation or no association. It's just randomly, things are just random. And over here we have a negative one because it's going down from left and right. So we have a negative correlation and we have, or a negative association. So with this one right here, what do you think you could make with it? Kind of, what would you put for an X and what would you put for a Y? So try that. Okay, well, over here we can put, let's say this is the number of mistakes you make. So we can say mistakes right here. And over here would be your years of experience on the job, or maybe in professional baseball, right? We just mentioned the Mets before. So let's say the more years that you play baseball, the less mistakes you make in the game, right? That's plausible. That could happen. And as you can see, let's say it's going down, right? Now, if we added more things, let's say we had something here, you know, there's a bunch of lines here. What would we call this? What was that term we said? If anyone remembers. Well, this would be a cluster, right? This is a cluster because everything's clustering together. So there's a cluster here. And then with a line of best fit or a trend line, we're trying to get the right down in the middle, at least somehow. Try to eyeball it. So you have just the same from one side of the line to the other side. That is called the trend line or line of best fit. So we can make a prediction. And we can get the equation of the line of best fit or the trend line the same way we would get a linear equation, which we've done before. So you got to get the slope. So we'll do a few of those. Okay, so let's look at one with graph paper, this chart here. So you have to be careful with this because the numbers, you don't see all the numbers here on the X. Right, so between 14 and 18 is 16, so you got to remember that. And then here, if you're looking at between 140 and 180, that's 160, right? You have to be careful. So let's look at what points we have. So if we look here, there's a point here, that dot there, there's one point on the line. You want to look at points on the line. Again, this is the line of best fit or this is the trend line. So with this one here, it looks like it's above 160, so we can say 170. So we have one with 170. And that point seems to lie a little past the 16 and 18, so we'll say 17, 160. 17, 170. So there's our first point. Now, let's look for another point. Well, here's a point on the line here. Looks like it's on the 5, and then a little above this one right here, which would be about 50, because that line would be 40, right? 20, 40, 60. And that point right there is about above it, so we say 50. So we have another point now. We have a point of 550. So now we can make our slope, and then we can make our equation. All right, so here's our points, 17, 170, x and y, x and y. We did the change of y over the change of x, rise over run. 170 minus 50 is 120, 17 minus 5 is 12, and our slope is 10. So what do we do with that? So we know so far our equation is y equals 10x, and it's going through the 0, it's going through the origin, so that's what it is. There's our equation, y equals 10x. Right, so when x is 5, y is 50, just like it said. When x is 17, y is 170. So here's our equation. This is our line of best fit equation, or our trend line equation. And we can make predictions based on that. So as we see here, it is going through the origin. That's where the y-intercept is. And it's making a trend. Now you can see there's not that much data on this scatter plot. They're very close together here. So this is a strong positive association or a correlation. Now sometimes, you can have more, you can have more them scattered. We'll just put a few more of them scattered. So when someone was doing statistics, when they were looking at how people read or what books they were reading,
And when they had, maybe when one book had 2 chapters, maybe this is the amount of pages it had. You never know what type of book it was, right? So there are many books here that they're working with. And this, right here, if you were a statistician, you would say, wow, there's a really strong correlation. But if you saw something here, clustered, right, that would be like, you would say, what is happening there? Because there's a cluster going on there, or over here. Now here's one, and we can use, this is, let's say this was planets. The closeness they are, the proximity to the sun, let's say, the closer you were to the sun, and the temperature. So this would be the distance from the sun. So it makes sense that a planet closer to the sun would have a higher temperature than a planet that's farther away, right? It makes sense. So we have a negative correlation going on here. Make that straighter. Now, of course, there are exceptions. Like on Mercury, for example, is hot. It's the second hottest planet, but it's closer than Venus, right? Venus is further away than Mercury, but Venus is hotter because there's other factors involved. Venus has a cloud cover. And then also on the other side of Mercury, it's colder than Earth. So there's a lot of factors that go on in here. Now, if you saw this, a couple of those, what would you call them? Well, they are outliers, right? These planets are so far from the sun, yet they're hotter. They're hotter than some planets over here, right? So as a scientist, you would look at this data and say, well, something's going on here. And the same could be said if there was an outlier here. You would want to know why this planet is so cold, like we said with Mercury. On the other side of Mercury, it's very cold. But for the whole planet to be cold on average, that's something has to be looked at. So, okay, so that's scatter plots. Let's just put one more thing. Let's do a trend line. Where do you think the trend line should go? Right, so if we just roughly put a trend line down, and you want to use a ruler for this, you want it to cut it in half somewhat. You want to have, it's a little off here, but we know there's our trend line, and we can make an equation based on our trend line. Okay, great job.